for this problem, I am going to also remind you of what the graph looks like of the integrand. Graph y equals 1 over x squared. If I plug in 1, what do I get? 1. If I plug in 2, I get 1/4. Now I'm going to exaggerate this a little bit. I'm putting it higher than it should be. What if I plug in 3? 1/9. And if I plug in 4, 1/16. You do have a horizontal asymptote, that's the x-axis. If I do a little bit more of this graph, if I plug in 1/2, I'll get 4. I have a vertical asymptote, the y-axis. What's the other side look like? It's above the x-axis. If I plug in -1, I'll get +1. If I plug in -2, I'll get 1/4. -3 gives me 1/9. -1/2 will give me 4. So here's this graph, y equals 1 over x squared. What I'm looking for in this problem with this integral, if I think of it as the area, I want the area from 1 to infinity. So the area part goes on forever. I'll write this integral as the integral from 1 to infinity of 1 over x squared dx. So I need to write it as a limit. So I'm going to write the limit as b approaches infinity of the integral from 1 to b of 1 over x squared dx. For me, it's helpful to see instead of 1 over x squared as x to the -2. That's just the way my brain operates on this. If I don't write it, I have to think that. And then I have to, okay, and then what we're going to do, add 1 to the exponent. So the limit as b approaches infinity of x to the -1 over -1, or if you just want to put that negative in the front. Now, when I put x in the bottom, what negative am I getting rid of? The exponent. So this will be -1 over x, and that's the limit as b approaches infinity of -1 over x from 1 to b. So the limit as b approaches infinity of -1 over b minus -1 over 1. This time, as b goes to infinity, what is 1 over b going to? This goes to 0. So this becomes 0 plus 1. At this point, once I've taken the limit, I take off the limit as b approaches infinity. This is 0 plus 1, which is 1. So I have found that this area from 1 to infinity is actually a number, is 1 square unit. I like to look look at the book for a minute. This is typically in every calculus book, they have these two problems. And here, I'm showing these two graphs because these are computer generated and a lot more accurate than what I drew. So here's my y equals 1 over x squared. From 1 to infinity, this shaded region is a finite area. It is 1 square unit. And this shaded region from y equals 1 over x from 1 to infinity is an infinite area.